Hi guys, this is Mrs. Lynch. I'm going to be doing the limiting reagent percent yield worksheet, problem number 1. All right, this is the problem that's on that pink worksheet. For the following equation, 4 aluminum plus 3O2 yields 2Al2O3 or aluminum oxide. We've got 4.5 moles of aluminum, 2.6 moles of oxygen. We got to find the limiting reactant, find the number of grams of the product aluminum oxide formed, and find the number of moles of excess reagent. This is a limiting reagent or limiting reactant problem, so we need to do a BCA table. I'm going to rewrite the balanced chemical equation off to the side or on a separate sheet of paper, and then I have to make my BCA table. Remember that BCA stands for B before, C change, coefficient also starts with C, which is important for this row, and A after, BCA, before, change, after. All right, remember, only moles go in the BCA table. So let's fill in what we know. According to the problem, we know there are 4.5 moles of aluminum, and we know there are 2.6 moles of oxygen. Whenever we start a chemical reaction, there are no products. So I'm going to put a 0 under the aluminum oxide. Okay, now we got our before row filled in completely. Got to work on our change row. The biggest change that we're going to see is a formation of a product. The formation of the product depends on how much reactant is used. But I don't know which reactant is the limiting reactant yet. So I'm going to split this box in half and determine how much product aluminum oxide could be formed if I use up all the aluminum on the left side and all the oxygen on the right side of that box. On the aluminum side, if I use all of it up, I could form 2.25 moles of aluminum oxide. That is because I have 4.5 moles of aluminum to begin with. There is a 4 to 2 mole ratio of aluminum to aluminum oxide. So I'm dividing that by 2. 4.5 divided by 2 is 2.25. If you guys can't see that, here it is in a proportion. Possible aluminum oxide, if all aluminum is used, in a proportion. 4.5 moles of aluminum over X moles of aluminum oxide. 4 moles of aluminum oxide to 4 moles of aluminum to 2 moles of aluminum oxide also gives me the 2.25. If I use up all of the oxygen to use as my limiting reactant to make aluminum oxide, this one is a 3 to 2 ratio. I better do a proportion. All right, so now I've got my proportion. 2.6 moles of oxygen. I want to know how many moles of aluminum oxide that is. Pull down my 3, pull down my 2 from my coefficients, cross multiply, divide, and I come up with 1.73 moles of oxygen from oxygen making aluminum oxide. All right, now I have a 2.25 versus 1.73 moles. I can never make 2.25 if I use up all the aluminum to make that possible aluminum oxide. 2.25 is an impossible yield. I'm going to cross those out. But I can make 1.73 moles of aluminum oxide if I use up all my oxygen. So this is going to be my theoretical yield in moles. We never write theoretical yield in moles, but right now that's what I'm going to call it. We usually write theoretical yields in grams. Okay, let's keep going. Now, I know that my limiting reactant is oxygen because that is where my possible yield comes from. And whenever I have a limiting reactant, I'm going to use up all that reactant. So in my change row, I'm going to subtract all 2.6 moles I use up. And after, I'm going to have no mole left of that reactant. In terms of the aluminum, that's now my excess reactant. I have 4.5 moles to begin with. Now I have to find my change of aluminum. Well, if I take a look at how much aluminum oxide I could make 1.73, if I use up all my oxygen, I want to find out how much excess reactant I've used. Well, let's see. This is a 2 to 4 ratio, or I'm doubling the 1.73. This is it in proportion. Change in aluminum of 1.73 moles of aluminum oxide is made. I am either multiplying before divided by 2 or just doubling this to get 3.46. Remember, I'm using up reactant. This is a subtraction problem in the change row on the reactant side. Okay, to find my after box, 4.5 minus 3.46 gives me 1.04 moles. Whoa, we just did a whole lot of BCA table. Good job, guys. Now we can answer those questions on the left, 1A, B, and C. Find the limiting reagent. Awesome, we did that. O2. Find the number of grams of Al2O3 formed. All right, I know this in moles. I want to find grams. I'm going to take my 1.73 moles and I'm going to find the number of grams. Here's my proportion, 1.73 moles of aluminum oxide over X grams. 1 mole of aluminum oxide, according to the periodic table, has 102.0 grams of aluminum oxide. Multiply through, I get 180 grams of aluminum oxide. This is my true theoretical yield. Remember, theoretical yields in chemistry expressed in grams. Last part, find the number of moles of excess reagent. This one, easy. I just got to take my 1.04 moles from my data table above. I put it down below. 1.0, sorry, you might not be able to, oh, there it is, 1.0 moles of aluminum, because on this one, I have to make sure I watch my sig figs. 182 sig figs, 1.02 sig figs, all coming from my 2 sig figs up above. Great job, guys.